Hello, my name is Zachary Lancaster. I'm an engineering manager with Warner Brothers Discovery, both Mamta, and I'm here with my colleague Mamta Gupta, who is a staff analytics engineer, also with Warner Brothers Discovery. We work on the WBD Common Data Platform, also known as Bolt. So if at any point you hear me say the word Bolt, right, I'm referring to our Common Data Platform, which is where all of our various businesses come to put their data in one big warehouse. I'm here, so that's me. I wore the shirt. I was going to put that Simpsons meme in there. That's like, oh, he said the thing. And then I didn't have time to do it. I'm also here with Mamta. Let's go ahead and start talking about what we're going to do. So we're going to go over CNN-specific data platform. So I said that there was this one thing called Bolt. There's another thing called Zion. Zion is the CNN data platform that still exists. It's being migrated. We're going to talk about how that got implemented in DBT Core. We're going to talk about how we went from core to cloud. We're going to talk about how we scaffolded that up as infrastructure as code. We're going to turn about what we learned and what we're going to be doing in the future. And then we're going to hopefully have time to let all of y'all ask questions. And frankly, if not, feel free to grab me after or us. So what is the platform? So it's called Zion. It is a Matrix joke. We own that. It's a WBD property. So we can say that. You cannot name your platform Zion, otherwise David Zaslav gets angry. It's made up of a lot of different pieces. So we basically have a collector that starts with a bunch of stuff that happens in AWS. Then we have a transformation layer that takes advantage of Snowflake and dbt and Airflow. And then we have a service layer on the far side where all of our tenants, all of our stakeholders and tenants build their various data products at the other end of our analytics pipeline. So it is a fully first-party data platform end-to-end SDK to dashboard. So it is built with designed for resilience and designed for scale. It moves around about 100 terabytes of data a day. It can scale by 15-fold at the drop of a hat. And it ingests about 1 billion events a day. This is large. It is not huge. But it presents a lot of problems, as one can imagine. So this is data built to support breaking news on a day-to-day basis, and it has to cover identity resolution, behavioral events, and profiling. We have to ingest content metadata so we know who's consuming what, when, and where. And we have to process all of that into core business semantics that make sense and drive value to our stakeholders. And those are all going to be generated to create those business critical metrics that people use on a day-to-day basis to decide not just like what's important, but how it is presented. So the Zion system at this point really drives two big main functions: content analytics and our ML recommendation system. Those are the two kind of big pillars that make up what it powers these days. And it is built on DBT Core. So why DBT? So DBT is modular. DBT is automated. It allows people to see what they are processing, how it gets there, where it came from. It has given us a lot of ability to test and validate that the data and that the decisions we're making are true, and it has integrated seamlessly with common engineering practices and CI/CD, which have made getting those changes out and into the world much easier. And it has allowed us to have scalability across this scale of data. So we can write test models, we can dynamically change a specific model's provisioning just by way of configuration, and we don't have to go and do a lot of fiddly stuff in Snowflake to make it happen. And it's cost effective. Hint, DBT Core doesn't really cost you anything, but it also doesn't increase your SQL bill. So let's talk about how we got here. So digging through GitHub, I can find the earliest hints of Zion going back to 2017. It adopts DBT Core in 2021 when one of our engineers, Sean Halliburton, discovered it and got very excited. It was scaled up for use in CNN+. Who remembers CNN+? Ooh. That's why it's not here anymore. And we adopt DBT Cloud in 2024 after doing a brief POC and realizing its potential to help our stakeholders really realize that last mile journey. And we are, in 2025, scaling out that DBT deployment to support a multi-platform approach, allowing people to take advantage of the tool they want on the compute they want over the same common data. So again, let's look at the scale of the project. So we talked about the scale of the platform. The scale of the project, it has 450 models that's only in the core deployment, right? That does not count any of our ancillary, anything that is in the orbit of it anymore. It's covered, about half of that is covered with about 1,600 tests. A majority of those models run every hour, and they can run consistently with a 10-minute variance, and that is across all of that spikiness in data. So as you can imagine, when something happens, like somebody runs let's imagine something like an imaginary person runs a tanker into a bridge, and people keep scrubbing through it to watch it hit the bridge over and over and over again. We can process all of that, and it only takes us about 10 minutes longer when we have a really high volume day. So in core, we have 3 major layers, as it follows kind of a standard version of the medallion architecture, and runs across multiple DAGs that support multiple time aggregations. And it gives our machine learning and data visualization teams and other things, it gives them their own functional areas to process the data, to have the data processed for them. And it looks something like that. So this is the overall architecture. Again, just to kind of rehash what was discussed before. This all flows through AWS, goes through Snowflake, and then we make use of a lot of different tools on the outside to make sure that all of that is working. And the nice thing about dbt Cloud is this all just works seamlessly out of the box without changing very much. So it has actually just made everything easier to maintain and manage. And if anything, our integrations with Datadog have been a lot better. So I'm going to go ahead and start turning this over to Mamta to let her begin to discuss why we did what we did, and why we started, and how we started making the transition from core to cloud.
Thanks, Zach. As Zach mentioned, dbt core was working fine for us, right? But every system comes with some limitation and challenges. And our came with inconsistency in job performance, leading us to unpredictable, unreliable outcomes. Scaling, infrastructure scaling, again, with growing data needs every day, and some unforced situation like Queen's funeral. Our system failed, like it fails or it faces challenges to scale and that extent. There is a huge dependency on engineering team on any business analytics. We want our stakeholders to be independent. And with 450 plus models, it's a monolithic project, right? It doesn't support a mesh architecture. With core to cloud migration, we wanted to get a best approach for our stakeholder to guide them to take their decision and launch their data product independently. And hence, we wanted to make sure that we understand that the technical problems and all the technical problems that we have versus the organizational problem that we have. As an engineer, I found that Zion project is really challenging to navigate through, especially when it comes to navigate through a concept or a semantic, right? Breaking Zion into smaller conceptual, more manageable chunks, breaking the project into smaller conceptual chunks, and then managing the dependency using dbt mesh could make it easier to understand and also easier to navigate. Second problem, like we face the failure every now and then, causes job independency, job inconsistency, and hence we face frequent failure causing inconsistency in job, right? To implement fault-tolerant mechanism like automated retries or handling the error better can enhance the job performances and hence also optimize the cost. Our system is very rigorous, resource intensive. It also causes the high operational cost and again, the efficiency of the job impacts, right? Streamlining the pipeline using optimizing resource allocation, implementing efficient processing techniques, and leveraging cost-effective cloud resources can improve the cost and also the performance of overall pipeline. As Zach mentioned, scalability is a challenge. Like we have so many unforced situations like Queen's funeral to the regular planned event like presidential debate, right? The data scales up and our system faces challenges. During that scaling, incorporating distributed processing, load balancing, or horizontal scaling can improve and accommodate that kind of scaling. As a stakeholder, I found it is difficult to secure like continuous support from the engineering team. And I want my system to be self-serviced so that I can deploy my own data product. How can I enhance, as an engineering manager, how can I enhance the developer onboarding or experience of an analyst? By providing a robust deployment tooling, project scanning is using dbt Cloud Scheduler, or automating the common component deployment like environment variable, or jobs, can give a developer a platform which can ease the deployment for any new project or ongoing support. Coming to that ongoing support, we don't only want the deployment easy, right? We want to make sure that the ongoing support is also stressless for any developer. To create a centrally controlled project with common macros, reducing the redundancy in the code can provide that kind of better tooling to the developer. Yeah. As an engineering manager, I want all the notification coming directly to my engineering team so that they can mitigate the problem as soon as possible. Enhancing the alerting or monitoring system using dbt webhook, sending the Slack notification directly to the team, can enhance that kind of developer or support experience. Keeping all these things in mind, yeah, we decided to migrate to the cloud. But we also wanted to make sure that we have a migration plan in place which has minimal yet maximum impact, right? So we decided to start with the POC which has something easy or easy to understand, break the pipeline into and isolate that pipeline from Xion ecosystem. Enhance, look back, what we did wrong, where can we enhance? Then start building the tool out of the macros, like start taking out the macros in separate repo and start working on the project tools. Pick something else easy, which again is not going to impact the Xion ecosystem, still have some relation with the first project so that we can test the functionality like dbt mesh. Build up and standardize the whole project so that we can have better observability and maintainability. Implement the whole framework end-to-end. Add the observability and monitoring system on top of what we have so that we can enhance the support system. And that's it. We hands off the final project. Coming back to the migration strategy, right? We wanted to make the Xion architecture simpler, breaking it into more manageable and conceptual, supporting different semantics at once, can make the architecture simpler and easy to understand. We just don't want to move from core to cloud, right? While doing this migration, we also wanted to enhance our pipelines. Going back to the code, looking back and see how can we make it more simpler and efficient? How can we enhance the testing to increase the code legibility? Infrastructure as a code. Yeah, everyone is talking about that, and we wanted to implement that in our system as well, right? Centralize our tooling, taking out the common code, making everything generally available for any project, not only our project. With infrastructure as a code, we also wanted to make a push button deployment, right? With the support of additional tools and technologies like Terraform, Terra-granted, we streamlined our dbt project deployment as a push button deployment.
And I want to jump in and say that one of the things that this also does is it ends up making it possible for us to switch out data sources and switches in without complete transparency to the stakeholder. So as we evolve our data strategy, we have control as an engineering team over what resources are the most optimal for a team to be using without them needing to make that decision on their own. We can run the cost metrics, we can run the projections, and they can just get the benefit.
So if you go to the next one, yeah, that's how we enable the domain expert to use their expertise, not understanding the technicality, but using that domain expertise to launch the data products. infrastructure as a code. I can't stress more. We definitely wanted the infrastructure as a code as easy as possible, right? So choosing the right orchestration tool, where to use dbt versus where to use Airflow, was critical. It was first step to do. A complex run environment where we need dynamic incremental loads or dynamic variable setting, we stayed with Airflow. Versus the small standard simple incremental loads, we went with the dbt cloud. Non-standard incremental process, like Zion has so many non-incremental processes, I can't say it, but loud. But 15-minute load looking back to 2 hours data versus hourly load looking back to previous 1 hour, previous 5 hours, and I don't know. So those all non-standard incrementals still stayed in Airflow. Versus we had, there are many dashboards which need a quick refresh. That moved to dbt cloud. With Zion, we keep getting ad hoc requests for backfilling for the previous specific period of the data, and that stayed in Airflow because we had the plugin all set for that, right? On top of Airflow and dbt, we had Terraform and Terragrant to improve the deployment. With Terragrant, we have reduced the number of script that is used to do the deployment, and then on top of that, code build is there, which actually have no manual interference for the deployment. So it's all fully automated now. What we achieved with this, right? It gives you a quick start template with all common macros and tool in one place. We have a start template to launch any new project or deploy any new project to dbt cloud. We have better alerting and observability, sending back the notification directly to engineering team so that they can react to the issue as soon as possible. Even if we have this project out of the Zion ecosystem, we can still tie it back to Zion and link it using dbt mesh or other architecture like sources. We did the automated deployment, right? Like end-to-end deployment is automated now. Just copy a set of infrastructure code and then that's it. You have a new dbt project ready. Where are we now? So we started the POC in January to 2024 with migrating a handful of models. Our first project was launched in Feb. Then we looked back, did some refinement, identified what is missing, what needs automation, deployed the new Terraform modules, like Terraform modules and common macros and tooling in late March. April, we started with the second project, which actually utilized the dbt mesh, tying back to the Adobe project. Then the alerting system has been improved using dbt hook and Slack notification. Multiple projects went in June, like social media growth, underscore many projects. And last but not the least, we have the observability in place now, and the additional projects are deployed. In August, it was maybe I can say one of the biggest achievement that we have our analytics research and testing team onboarded. And they are doing their own deployment. They're utilizing dbt cloud UI to write their own models and do the deployment as it's all automated, and we have the project ready for them, right, with the tooling. This is how our current overall dbt cloud architecture look like. Like we have all these project separate pipelines running in cloud. Then we have common code base for all the common modules that is in dbt and common macros, and infrastructure as a code in another repo with all the infrastructure related code. We feed to all the BI reporting tool, you name it, like Domo, Tableau, and Looker. And then we have data governance in place using Datadog and Monte Carlo on top of everything. So where are we now? What is the impact of the transition? We implemented a multi-project framework using dbt mesh, making the whole project easier to understand and enhanced the project organization. this new platform is embraced by data analytics and research team, as I said, like they're using dbt Cloud Explore to understand the lineage and work on their own data products. Runtime has been improved a lot. As we move to cloud, we also improved the job performance. Like our content pipeline has been running for 2 to 3 minutes, coming down from 10 to 12 minutes, which is like, I don't know, 75% of efficient. Monitoring and alerting system has been improved a lot, like dbt webhook, integrating dbt webhook with Slack and switchboard warning. We have enhanced monitoring system, which has been proven like beneficial for the engineering team, right? While doing this all migration, we have been monitoring the roadmap and have developed the roadmap which can help us grow and deploy new project in future. Again, with dbt Cloud, we have improved documentation system, right? Like project level, model level, and column level lineage. We have everything. So anyone can go and look back, do the impact analysis. What we have learned from this whole migration, we have enhanced or clear insight of our whole pipeline, or all the components in the pipeline. We have simplified the project architecture, and we understand the value of it now, right? It has improved the clarity and efficiency of the project. It is easier to maintain the integration among these projects, and it is very straightforward, more straightforward than what we anticipated. We have learned that careful orchestration is essential, and that's why we continue to use Airflow when needed. But we are not going to stop there, right? Like there are many upcoming features coming in future, like creating new document support materials for anyone or anyone onboarding into the project. We will be adding more observability using dbt test or using more Monte Carlo or Datadog dashboards. We will be adding it. This splitting Zion might be the major upcoming enhancement. So all different conceptual areas are out of Zion, but Zion is still in core, right? We want to split it and maybe do the partial migration, parallel, horizontal or vertical, haven't decided yet, but that split is coming soon. And adding dbt to the CLI tool for full self-service for the technical teams. Like we want to provide a full self-service platform for the technical teams in 2024. And I think the cross-platform dbt mesh might help in this one, because we want to support the multi-compute use case, like whether it's a Databricks or a Snowflake. We want our system to support that, and with today's launch, maybe it will be easier, and we should be able to achieve it in Q1 2025.
And for example, like there will, even as CNN looks to migrate to Bolt and to become a part of the common data platform, there will likely always still be data, either historical or that is unintegrated or specific to the tenant itself, that will need to be integrated. And so being able to support this multi-compute or multi-platform service is going to be very critical, and making sure that that is available out of the box even more so. So we are targeting January 2025 to finish splitting things up. I think that leaves us 4 minutes and 5 seconds for questions.
Thanks, everyone.
Thank you, everybody. You keep it for questions. Yeah.
Thanks, guys. Great presentation. I wanted to ask, so from your experience with all the migrations, so is it possible to have a hybrid approach, so having dbt core and dbt cloud at the same time? For example, analytics engineers working on dbt core and having analysts do all their work on dbt cloud.
Yeah, so this is actually a conversation we've been having recently, oddly enough, is this split between when to use cloud and when to use core. And if you think about it a little bit, there's not really that much of a difference, right? So but you have to take this kind of step where you build some kind of intermediate project. So you're going to have to figure out that place where actually your data crosses that line, right? So in our case, we kind of have that medallion architecture. We go clean and raw, clean, enriched. At some point, something becomes analytics. And so in our case, like what we've been saying is, like, oh, well, why don't we just like kind of like ingest this in some way, bring it up as sources, and then if that doesn't work into that multi-project lineage, what happens is maybe we just create views so that you can actually get that nice view all the way back. That will create kind of a horizon in your lineage where you say, oh, this is just sourced from the platform, right? And that will have its pros and its cons from an organizational level. It's really going to depend on how much of that human readable metadata you really want to be available, how much people find it useful. So there are teams that are going to want to know, I published this schema that goes into that event in the SDK that ends up on that topic in Kafka that gets consumed by that microservice that generates this thing, and blah, 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 dashboard, right? You're going to have those people, and if you cut that line, they won't be able to see that, and you're going to need some other kind of metadata tool on top of DBT at that point. So that's an organizational choice. But from kind of a technical perspective, there are definitely real reasons to say, I want this down here to operate in core, so I have really tight control over the orchestration of my platform environment. Then I publish effectively the outcomes of my platform to some common cloud layer, and then everybody consumes off that mesh layer on the other side. So oddly, that's the conversation that's been going on quite a lot as we kind of talk about what's next for DBT Cloud at an organization this large. Because you still want everybody downstream from you to be using it, and they are still going to be the main driver of most of your your DBT work.
Yeah, thanks for the presentation. I'm just curious, how do you orchestrate in complex multi-project setup with all the dependencies between all the models? So if you have like one DBT project, the model depends on another project, how do you orchestrate like along them?
So let me repeat the question so I understand. So in a large project that has many models, how do I make sure that in a large multi-project setup, how do I make sure that the dependency graph, a DBT made that easy?
Yeah.
That's why we use the DBT mesh, right? So we make the model public in one project and then access it using dependencies in another project.
Yeah.
And that's how we manage the lineage.
Thanks.
And it has worked great, I would like to add.
Where are you managing Terraform state? And is that centralized to a platform team that's managing all the infrastructure, or are you letting each team manage their own?
So I'll repeat the question for the sake of the recording. Where is Terraform state being managed? Is that being farmed out to the teams, or is that owned centrally? So the idea is that the main engineering, the data engineering team actually owns the entire platform infrastructure. So DBT Cloud is seen less as just a tool that is like handed out willy-nilly to everybody, and as a platform, as actually like a component in the platform's larger tooling strategy at CNN. And so what happens is the data engineering team owns all of that. So all of its state is managed within all of, you do your best practices for remote state, all that other stuff. So it's owned by them. So that team has full visibility in how that's deployed, how it's being used, what's being generated, how that's happening. So all that's fully available over here, and then the teams don't need to worry about it, right? So those stakeholder teams don't need to worry about it. They don't need to think about it, And if they stand something up and all of a sudden there's a state error, I guess, that'll be a fun Slack exchange.
Yeah, and so question around defining the project in DBT Cloud. So you mentioned that you had about 450 or so models in your monolithic project. When you moved to cloud, how did you end up deciding that this should be a project within core? So assuming you must have split it in multiple projects. So what was the right level you thought was, and what were the benefits of it?
Basically, we try to find out different concepts and models which has least impact. All the events related data still remain in the core, but like content metadata, which has least impact and still joining back to the main project, those kind of concept came out first.
To put a finer point on it, we looked at the lineage graph, and we found the places where the lineage graph kind of like, it would come in, and then would fork into it would kind of merge. So we looked at those fork and merge points and tried to take those lines that were independent. So as Mamta is saying, so it's just a different way of saying like there's no intrinsic dependency between the two. So do we have time for one more? Or are we good? There's one guy right here.
I'm curious, you mentioned that you use it for both content analytics and like recommendations for users. How much of that like analytics ends up being the same, or is it almost completely different? And like, how is like running the recommendation for you off of DBT working?
So our recommenders consume off of our very bottom layers. They either consume off our machine learning teams grab training data out of the end of the analytics pipeline, but their real value driving endpoint is off of our Kafka streams. So they're supported on DBT, but they're supported in doing their training work, and the ML scientists are supported in their experiments work off of this stuff. Their actual operational day-to-days are not supported by DBT. And it's kind of the wrong use case for DBT because of what they need to be doing. Sorry, Mark. It's kind of the wrong use case for DBT. You need, because you're doing these kind of machine-to-machine translations, right? You really do need them just like consuming that data right there. So if you wanted to look at something like that, and you do need to do transforms at that layer, you're going to be looking at something like Flink. You're going to be looking at something or like a microservice or some other real-time data processor, which then gets back into the importance of human-readable metadata, but that's a different conversation altogether. Thank you, everybody.
Thanks, everyone.